Good afternoon. My name is George McRae. I own and operate a full-service auto repair and truck repair center. I also have a full-service wrecker service, and I've been in business here for 38 years. Been in the automotive field since I was a boy. Started at 15, so that's 45 years. I have always had to fix the problem or else I don't get paid. I'm the boss. This car here, my techs went as far as he could go, and I had to get into it. It was a heating problem. When you started it up, it would start to push fluid out through the cap over into the recovery bottle. Once you got it to heat up and the thermostat would open, you could drive it all day. But one or two attempts at a restart, and it would lose enough coolant so that the temperature would peg and she'd have to pull over. So it originally came in for possibly a water pump, possibly a thermostat. Customer wanted those changed, which we did. The water pump was cheap and pretty easy. That was 19 bucks. The thermostat, we ended up putting 3 in before we settled on going to OEM. Even the OEM thermostat did not make a change. The thermostat is a two-stage, two-step, whatever you want to call it, type of deal. Has a sealing device on this end and a separate spring. The top part of the thermostat is pretty conventional. It's circumnavigated rubber seal, makes it really airtight. So we couldn't get the coolant to stay behind the thermostat long enough to open the thermostat, no matter what we did, without pinching off either the radiator hose, the top radiator hose, pinch that off tightly, or we would pinch off this return hose, which comes back from the intake manifold. Regardless, we tested the radiator caps. We tried 3 different radiator caps. Everyone tested good. Everyone reacted the same exact way. When we would shut the motor off, the recovery bottle over here would have small bubbles and fluid. Just for up to a half an hour it would leak by. At the time, there would be no pressure on the top radiator hose either, but there would be still that internal gases, pressurized, going by into the tank. So we determined that the radiator was still being ice cold. The heater core, which is hidden back in behind, ice cold. The hoses going to it were cold. You have this bypass, they call it a hot water bypass right here, that goes around and comes in and tees off and goes through the throttle body. We did find some contamination in that tubing going into the throttle body, but otherwise that pipe was clear. We flushed this thing and then we reverse flushed it. We checked the flow of the radiator. Radiator was clear. We checked the flow on the heater core. So coming down to this little piece here, this thermostat, this part plugs off a hole, an orifice, in the back side of the thermostat housing. And that is what feeds up through to the, from what we can tell, feeds up through to the intake manifold and then comes out directly in this pipe here. So it was our determination that if we pinched this off and everything seemed to work normally, what were we going to hurt if we eliminated that? We actually replaced this hose because it was rotted. We replaced the top radiator hose because it was rotted. Now, getting back to what I was saying about the pressure test, I think originally she lost coolant because this top radiator hose had a small perforation right in the top below the clamp. It was original hose, original clamp. And when we did the second pressure test, we must have got it just right because we had no coolant in that hose And all the way from 15 psi right down to 1 psi, we were still hearing a hissing sound coming out right here, but no coolant. So I believe that might have been a cold water leak, and just over the course of time she lost it. So that may have initiated the problem to start with. Anytime an engine overheats, of course, I will change the thermostat just to be safe, because you don't know if it may have been damaged, the thermal spring. But this little port plug right here, I don't know what you call it really. It's really just like a washer, and the spring holds against it, but it goes and plugs that orifice. So as this thermostat opens up, the pellet moves down, and it actually presses this spring tighter. So I got to thinking, I said, well, we need to limit the amount of coolant going through that intake manifold and coming out the other side. That's what this is supposed to do, is my opinion. I don't know, it's a really crazy plumbing system, and if you're watching this video, it's probably because you, like me, you searched it and you're having a hard time. I couldn't find anything that described this problem on the web, so that's why I decided to make this video. Now, the answer is, when I put this in for the final time, I had the OEM thermostat, and we drilled an 1/8 inch hole just below the rubber seal so that coolant could pass through, but also that would allow the gases to go by so that the coolant could come in place of it on the back side instead of being an air trap, so this spring wouldn't get coolant. Now the 1/8 inch hole allowed the gases to push out into the top radiator hose, and the spring would now see coolant, and then it would start to activate. Now the second thing is whether or not this was sealing well enough. I believe there's either a small imperfection in there, or maybe this is binding even with the new thermostat. I don't know why it would, but something is happening why this is not sealing off that coolant adequately, because the coolant from the thermostat housing goes by this thermostat up through the intake manifold and then comes out this pipe, which this pipe actually connects to this T, which is above the water pump. I don't know if you can see, it's above the water pump. So this return pipe here and this so-called what did they call that now? It's bypass, heater bypass. I don't know why they call it a bypass, because it's connected to the output of the heater core. So, but anyways, maybe because it bypasses the motor externally, I don't know, but comes right straight back to the water pump. So you've got this bleeder screw right here, right behind the radiator hose clamp, and then you've got a bleeder screw on this side. Both of them are low in comparison to the heater core, and both of them are actually below the radiator cap. So what they're trying to achieve, in my opinion, it probably has something to do with emission controls. They're probably trying to keep the intake manifold warm to a certain degree for better fuel, better management of the fuel going into the combustion chambers. I don't know, it's just my guess. So the answer was to fix this car, drill in this hole in this thermostat. I road tested it. It drove much better, no overheating initially. The temperature went up, going up hills, coming down hills, it cooled off, so I didn't like that. So I said, I'm going to the next step. This return hose from the manifold, intake manifold, behind this clamp, I put a piece of 5/8 round stock to plug it, and instead of a 5/8 passage now for the coolant, I drilled a 1/8 hole, so effectively reducing it down to 20% of the flow that it would originally have. So now, the way I figured it, that would force the coolant to take the path of least resistance now, which would be through the heater core, instead of that return pipe. And my theory turned out to be correct. Now I drove the car again, another 10-mile round trip, and the temperature stayed consistent. I've got 175 degree plus air coming out of the heater, and that is consistent. The temperature, the top hose has a light pressure on it when it's warm, and it's not pushing coolant out. I made a small mark, a small little black mark on the recovery bottle so that the customer can keep an eye on it, and I'm going to make them aware that I don't want it any fuller or any lower. And we've been resurrecting this car for a while. It has, I have to admit, it does have 265,000 miles. For a car like this, it's very surprising. But she really needs a car. This is what she has, so I'm doing the best I can to keep her going. But anyways, if anybody's got any problems with these, that's the way to do it. I hope I explained it somewhere near where anybody could get themselves out of trouble. But it isn't an intake manifold or some of those other things that I saw. It's nothing like that. This was strictly a flow issue. It's a crazy plumbing system. But like I said, drilling the hole in the thermostat and putting that restrictor. I put that clamp on there just to keep the plug inside at a location where I know where it is. I didn't want it moving around the bend or whatnot. But anyways, I hope this helps. I'm going to get back to my real job, which is operating a wrecker and trying to run this business. But every once in a while, I have to pitch in and help them diagnose these problems. Years ago, we had similar problems with K cars, if anybody remembers that. Thank you for listening, and I'm going to try to upload this properly so everybody can see it.